Everyone. Today we'll be discussing about the concept of routing algorithms. In that, only the three concepts which we will be learning in this session are the optimal principle, the shortest path routing, the flooding, and the other things we will be learning in the next session. Okay, so let's check out the various routing algorithms. First one, what is the optimal principle? The optimality principle, it's nothing but a route which is said to be in between. It is said to be called as the optimal principle. Okay, for example, your main route here, it is said to be I and K. So from source to destination is K, but it has to pass through the router, that is J. That is said to be the optimal point from where it is reaching from, like I to J. Okay, this is also a router, this is also a router, but the destinations from I to K, if it has to reach in between, it has to pass through the J. That is called as the optimal path. And whereas when the information has to pass from J to K, there is no optimal path. Only thing is that it is said to be J is becoming the optimal, which is reaching to the destination K. Okay, so this format, it is said to be having a sync tree. Okay, sync tree is nothing but a tree which is said to be having the sources and destination with multiple routes which are being provided from one end to another end. For example, here you can check out, you have multiple optimal points which are being considered in the diagram. So when you are said to be going from one end to another end, from this end to this end, this becomes the optimal point. Okay, from this end to this end you are said to be going. Then you have, it may be in between, whichever point is there which is being considered, it may become a optimal point. So it has multiple points, optimal points, when it is reaching from source to destination, which is said to be a part of a sync tree. So this sync tree, it may not resemble every time the same. The sync tree differs from one end to another end. Okay, one part it may, like from one place to another place, nearby places, it may like represent the same sync tree, but when it is said to be belonging to different areas, they may follow different types of sync trees. It doesn't resemble. Okay, this optimal principle has, it is not said to be represented uniquely in a different way. Other trees, like the paths in the sync tree, they are said to be differed based on the length, and may exist different types of sync trees. And mainly this sync like optimal principle was used for the development of the sync trees of the routers. Okay, this is said to be a optimal principle. Then you will be learning about the shortest path, as the name only says. So whichever route I want to like send the information from one end to another end, it will be choosing which is said to be the shortest one to reach to the destination. That route, it will be taken into consideration. That is the shortest path routing. So the shortest path, it may be based on the geographical distance, it may be the total number of hops from one end to another end. The number of hops may be counted, or it may be on the geographical distance you are considering the shortest path, and you are said to be sending the information. So it doesn't mean that okay, this path only it is being followed. Multiple paths may be there. So one path, if it fails, then it may following the another path. Through that path, it may be delivering the information to the destination. Okay, here the main aspect in shortest path, it may be considering the queuing part, and it may consider the transmission delay. Queuing is nothing but the information which has to travel through the route. It may be queued in the line, so one after the other it may get the chance. Or it may be happening that because of the queuing factor, you may have a transmission delay. Nothing but it has to wait for certain amount of time. So it may have a delay for 1 or 2 seconds, but not much. But maybe in seconds it may be having the delay. And this, even the shortest path will, like it functions based on the distance, based on bandwidth, based on the average traffic, the communication cost, the mean queue, nothing but length of the queue is being considered. Then you have the measured delay, it may be, and other factors which will be dependent on which the shortest path is being considered. Okay, so whenever the route is being chosen, it may be based on, like when it is developed in the beginning, only the cost factor is being checked. So whenever it is developed, it will check for the cost. It may cost more. That way it will be checking out. But nowadays it is not like much of the cost factor. It is based on the service which is being provided to the customers, in which it can deliver the information at a faster rate. So it is not based on your cost factor. It is based on how the distance is being maintained and how many hops it considers. That is the shortest path. So this shortest path routing is also called as the Adcnsession's algorithm. Okay, this Adcnsession's algorithm, it was based on this person, Adcnsession, who has developed this algorithm. This algorithm was said to be based on 2 points. One is tentative and permanent. So tentative is nothing but when a new connection comes into effect, I have to get connected from one end to another end. It's a new connection. Okay, so when it is new connection, it becomes a tentative. Like it is not like first time we are said to be experimenting the route, and if it reaches at a faster rate, delivers the information faster, then that route will be considered as the permanent. It may be used by multiple people, multiple destinations. It may be using that particular route. Then only it becomes the permanent route. Okay, so you have, in the beginning it will be a tentative route, then it becomes the permanent route, which was said to be introduced by the Adcnsession's algorithm, where it will be passing from multiple nodes from one end to another end. So let us consider one example here. What the example says. Okay, what the example says here is, you can check out a route is being considered which is being developed and it will be run. So from this source to this destination, your information has to route. So it may be following multiple routes which are being traveling from one end to another end. So I have to find out which distance is said to be less, and through that route only we will be delivering the information to the other end. For example, from the A point it has to start and move to the other destination. So I cannot consider this bigger route. I may consider the shortest route through which I reach to the destination. How do? I may come like this and I may reach to this destination. So it becomes very easier when I want to manage it. Okay, so what do? Is I choose a path here. So I may be considering here, I may move like this, move like this. I'll check it whether it is said to be a lesser one. So what do? Is I just find out the distance of the route. So I'm reaching from A to B, which is of 2 points. Then I am moving to E, which is of another 4 points. So 2 plus 4 is 6. 6 plus 5 is 11. 11 plus whatever distance is being considered here, that it will be counted. For example, 6. So it reaches to the destination. Or I may choose another path which is said to be taking here. It is nearly 6 plus 5, 11. So lesser distance I may consider now. What do? Is I have to move from here to another part. So I will be choosing this distance, 2, 4, 6, 6 plus 6, 12, and the destination I may reach. So it may be following different factors through which it can reach to the destination. This is a lengther one when I am reaching to the destination. So what do? Is I go from here, I go to here, then I move to this distance, and then this distance becomes very easier. So when I consider a longer route, when I consider like this, for example, I go here, I come here, this becomes a lengthier one. So what do? Is I choose a shorter path through which I can reach to the destination. So what do we do? 1, 2, 3, and here 4, which is becoming a shorter distance. I will be moving with the shorter distance length and reaching to the destination. So like this, we are said to be choosing the route which is said to be shortest one. So another one algorithm is there called as flooding. So flooding is nothing but at a time I will be putting the information onto one line, and that line gets the information diverted to multiple lines at a time. It may be like at a time I make the data flow to all the ends. That is said to be your flooding. Okay, and here the main disadvantage here in flooding is that it may prepare the duplicate packets. So in order to avoid this that duplicate packets to be arriving to the line, what do? Is mainly thing it has to be done is it has to use the concept of hop counting. Multiple times, how many times it has hopped. So it may be like double times it has hopped to the same part, then it is a duplicate. So that way the duplicate part is being rectified. Okay, and at the end, main aspect which is being used, the flooding algorithm, is in the use of your cable TV networks and all. This concept of flooding is being used, but at a time I cannot use to send the data of people to the other end. So over the internet I cannot make 1,000 people enter into the same line and transmit the information at the same time, because they may get hanged, they may be having the network issues. So it cannot be used in the internet facility where it can access the internet and give the internet facility to many at a time. It becomes difficult. So flooding aspect may be used in cable TV networks, like where you are using the concept of broadcasting, then only it is being used, this flooding. Okay, so this is the part of your flooding aspect. So we have discussed about optimality principle, then shortest path routing and flooding in this session. Okay, thank you.